So next we look into software health activities. And why do we care about software health activities or software healthcare? Well, the reason is that, identifying symptoms, and these symptoms would be technical debt, anti-patterns, bad code smells, poor evolvability, poor maintainability, whatever you want to call it. So identifying them is good, but what can we do? If we just identify, that's not enough. We also need to take care of these things. So looking next into the healthcare activities. And these healthcare activities come from the technical debt community that has identified prevention, then identification, monitoring, and measurement as a one. I have combined it here. And then we have prioritization, what should be fixed first, what last, and then repayment or budgeting for the repayments. And this is the technical debt management landscape from the paper by Nicoli and others. And they have identified tools and methods for these different phases. And according to them, they identified 0 prevention tools or methods. I don't fully agree with this, so I have listed something here as prevention methods. So we might have something like coding standards and style guidelines to prevent technical debt, to keep the software in good health. Here you see the style guide for Python code. And we can see that they give instructions on indentation, maximum line length, blank lines, source code file encoding, block line comments, naming conventions, and other programming recommendations. So this can be considered as a preventative health measure of preventing technical debt. Other types of guidelines can easily be found by just searching with any search engine, and they give several type of guidelines in all of them. Avoid deep nesting, avoid long lines, don't use lengthy functions. Anyone remember the long method code smell there? So these standards sort of give instructions on how to avoid bad code smells, or you can simply put do not do this in front of the bad code smells and let everyone study that. What has also been used is like the Bible approach. All the Christians in the course would know the 10 Commandments, and probably others as well that have been forced to take courses in religion, like we do here in Finland. But in this case, this is not religious at all. So we just have 10 commandments of programming. And this web page identifies what those might be. Ideally, you should customize them for whatever you are doing or for your company context. But in this case, the person has identified thou shalt name things properly, so proper naming conventions. Thou shalt not write obvious comments in the code. There is a line, get user from database, and there is a comment, get the user from the database. It is pretty obvious already from this function that the idea is to get the user from the database. Also here, send email to user, and then is the function that is called, and then there is a comment, send email to the user. Pretty pointless. The third one is you should not commit secrets to open source repositories. So if you have keys or passwords in your source code, obviously you shouldn't never ever commit them to any public repository anywhere, even if it's sort of private. So because there's always a risk that it leaks. Number 4, you shall not duplicate code more than once. So we can already remember in the code smells that duplicate code was the number 1 in the stink parade. Next one, you should not store passwords in clear or with weak hash algorithm, as those can be broken in the data, and then if there is a security breach, more passwords can then be extracted if they are plain text. And this has happened many, many times in the past, that the passwords have been plain text, and then, there is a security breach, someone breaks in, then they stole more passwords, and so they can keep doing the bad stuff as they get more passwords. You shouldn't steal other people's code. Yeah, you shouldn't do that. No unnecessary dependencies. Well, there was the design principle of low coupling between objects. Okay, comes already as 8. Thou shall not write tightly coupled code. Yeah, definitely not. Low coupling. Thou shalt not swallow errors. So basically this means that if there is an exception or if there is an error, you just cannot, do catch all exceptions and then stop and not put it any error handling mechanism that you might have. And if you don't have error handling mechanism, then you definitely need to create one. Final one in this 10 commandments is you shall not use hard-coded values. So instead of hard-coded values, it's better to use constant variables, enums, that you only need to change the numbers in one place, and having a meaningful name for the enums or constant that you are using. So then while you read the code, you clearly understand that, okay, number 2 means, for example, that we want to store the user to the database instead of retrieving the user or something like that. So if you have a meaningful name, making it much more clearer. And that was the 10 commandments of programming. I mean, it's not the 10 commandments. There could be others. It's a metaphor to make people follow the coding standards and trying to enforce some type of prevention measures for technical debt. Test-driven development is a good way to prevent problems of lacking tests, because when you do test-driven development, research has shown that the main benefit is that the tests actually get done. Otherwise, there's always the danger that you don't do the tests. If you do them first, then you are more likely to do them, and then you don't have this health problem of not having regression tests when you need to release the code again. In general, good practices and processes for software testing, software versioning, building software, educating people and sharing knowledge can be a very effective way of preventing software health problems. Okay, moving on to identification, monitoring, and measurement. We can see that there are plenty of tools, plenty of methods identified here. I have combined the identification, monitoring, and measurement because I don't really see a difference here. I mean, if you can identify something, then monitoring is just re-identifying the same thing. So if you use check style to identify a problem, then monitoring is basically you just rerunning a check style and tracking it maybe on a spreadsheet or through some visualization. Measurement would also be extension of this. So if you can identify check style warnings, then measurement would be just counting these warnings. So it makes sense to combine them as one. And as we can see, there is no shortage of tools and techniques here. So we have many tools to track code quality, code depth, and test quality, test depth. We can consider these tools as automated code inspection. And these tools are basically static analysis tools of the source code. Well, at least the code quality tools are. So, and this is coming from the compiler technology. So a program compiler or interpreter statically analyzes the code and knows a lot about it. Variable usage, find syntax faults, etc., etc. And so static analysis tools simply extend this knowledge. And here the goal is to check violation of coding conventions, ensure the system design and structure quality, and maybe detect coding errors or defects. Code metrics and code violation checkers have passed the market test. And what do I mean by the market test? Well, they have been around a very long time, and still they are available and people are willing to pay for their usage. So if we look at some of the first code metrics and code violation checkers, cyclomatic complexity was introduced in 1976. In 1944, in HP, they found that cyclomatic complexity of Fortran program was not to exceed 14 based on previous modules change data. In 1978, Lint program was introduced in the Bell Labs. I guess it is currently called Nokia Bell Labs. And what this Lint does, it examines C program source code and detects number of bugs and obscurities. To have more modern version of this, here is an example from SonarQube. Or from Sonar Cloud or Sonar Lint. I guess they have a product starting with Sonar with multiple different ones. So this is a commercial product. I'm by no means endorsing it. I'm just demonstrating that they are still available. So the cyclomatic complexity rule is still in place. So they have a rule, method should not be too complex. And it says the cyclomatic complexity of method should not exceed a defined threshold. And they provide a default threshold, but you can also define your own. And as we saw in 1994 in HP, for the Fortran programs, they determined that this number should be 14 or less. For Java programs, for Python programs, you probably want to do smaller methods, smaller functions. So it probably should be less, maybe something like a 10. They give a further explanation here. Complex code can perform poorly and will in any case be difficult to understand and therefore maintain. Then we have a Lint example here. Unused assignment should be removed. And what this rule says is that a dead store happens when a local variable is assigned a value that is not read by any subsequent instruction. Calculating or retrieving a value only to then overwrite it or throw it away could indicate a serious error in code. And even if it's not an error, it's the best waste of resources. Therefore, all calculated values should be used. And here is an example of non-compliant code. So you assign value to I, which is the sum of A plus B. However, on the next line, you assign a value I again, which is return value from this compute. So this line doesn't do anything. This might be an error because this value of I is never used. It is simply overwritten. It's an error or it just looks very weird. And a compliant solution would be I equals to sum A plus B, and then we add compute value to the value of I. So maybe here in the above, we are missing the plus sign. So this could be an error, or we simply remove this line altogether and we keep only the second line. And this type of error is something that a Lint type of program would detect and has detected over several years already. Identification, monitoring and measurement when it comes to test depth. There is many test coverage tools that give you metrics on the number of classes your tests cover, number of methods they cover, number of code lines they cover. And then we can go even deeper beyond the code lines. This is the point where many people are like, wait, what? There is more than just covering all the code lines? Yes, there is. There is condition coverage, then there is multi-condition decision coverage, And then there is even more absurd cases. But this multi-condition decision coverage is the most thorough coverage that is actually used. It was created at Boeing, and it is required for aviation software. See this documentation, software considerations in airborne systems and equipment certification. And what does this mean? Well, if you have a condition, A is less than 0 or B is greater than 0, in code line coverage would just mean that you execute this once and then you are happy. However, in multi-condition decision coverage, you have to cover the following cases. You have to cover the first one being evaluated as false, while the second one is false. Then you have to evaluate the first one being false while the second is true. And then finally, you have to evaluate the case where the first value is evaluated as true and the second one is evaluated as false. So the only thing you do not have to evaluate is where the first one would evaluate as true, meaning A is less than 0, and the second part would also be true, meaning that B is greater than 0. So the only one that is missing here is true. Okay, we arrived to the prioritization, budgeting, and repayment. The article indicates that there are some tools and some techniques for this. We should first consider that not all debt can ever be paid. So you cannot have a debt-free system. Therefore, it is very important to prioritize the debt. Which debt is the one that has the highest interest? That is the one that should be paid. Or which debt has the lowest cost of repayment? That is also another consideration of the debt that should be paid. Some prioritization things you should consider. First, we should consider time to fix. Like, how expensive is something to fix? So if we fix something, how long does it take? How much does it cost? Then the second is the risk of fix, which doesn't really connect with the debt world. So some repayments might be risky in the case of technical debt. So even if you do the risk, you might accidentally break something. So then there is a risk of paying that type of debt. Some fixes could maybe be automated. Some fixes would have a high quality impact versus having a low quality impact. Fixes should probably be done to files that are modified very frequently. So if there is a file constantly modified by many people and there is a technical debt there, then it's likely to influence many people. Also the modification frequency. So if you're constantly changing a file and it has a technical debt, then you probably should fix it as well. And many more criteria. So it is essential to keep track of the technical debt and then fix the ones that are, well, easiest to fix and has the highest impact, basically. Budgeting is also very essential. Thinking about, and budgeting, I mean when to do the repayment. So if you do not think about it, it will not happen. You will not find the time in most organizations. And some might be asking, so how do I do this budgeting to my manager? And Martin Fowler's advice is that, what do I tell my manager about refactoring? You don't. You consider it as a part of your engineering ethic to do a good job. So you want to do a good job, and then refactoring is just part of building a new feature. So you refactor, you repay whenever you start working on something new. So if you do a new feature addition to somewhere and you notice that there is a technical debt problem, then you start by refactoring it. And you don't mention this to your manager. You just do it because you want to always leave the code in better shape than what it was when you started working on it. And this is what we know as a sort of a feature-based approach. So every task, every feature has some refactoring attached to it, if there is a need. So first you look at the code. If it's good, then you can go. If it sort of looks bad, then you do the fixes first and then you add the new feature. So feature-based, task-based approach to budgeting repayment. The second one is the task approach. This was first introduced in Microsoft, the 20% tax of rewriting a code. And you can implement this in many ways. You can do the rewriting or refactoring or the other repayment 1 day a week, perhaps, because 20% would be a 1 day a week. So every Friday you do refactoring. You maybe do 1 week of a sprint. So if you have a 4-week sprint, the first week you do refactoring. If there is, and this is for like refactorings that have bigger needs. So you need to first do some kind of big change in the first week, and then in the second week and third week you do the feature additions. And this sort of 1 week approach might be actually more difficult to hide from your manager. So the hiding from your manager works better with the sort of the task-based approach. However, if you manage to introduce this 20% tax of rewriting code as a part of the organizational culture, then it might be great. I mean, you might use the argument that, well, Microsoft has been doing this since 1990s, so they have been doing it for 30 years. So maybe we should do it, because Microsoft is one of the leading software development organizations in the world. So maybe that might be a good selling point. So 2 approaches, the task approach and the sort of the tax approach. And this lecture has been focusing a lot on the code, design and architecture, depth and depth management. We slightly also covered the test depth part. And the reason for this is that most of the research is here. Most of the tools are here that can sort of automate this. We don't really have a tool for, people depth management. These others are definitely interesting areas, and they would definitely be relevant for software organization. So the focus of this lecture is simply what is available. I think what should be available is also these other parts. But this is left for future researchers like you.